Hello, guys. Today, again, we are going to do one more practical in OpenCV using Python, our image processing series. And today's practical is on image thresholding. Yes, the session is going to deal with the simple thresholding process. And in the coming lectures, we are going to go through more specific one like adaptive thresholding. Okay. Now, today we will focus on the thresholding process. First, we will discuss about the concept. Then we go for implementing the practical in OpenCV. So, what is this thresholding? In this thresholding, we try to threshold the image in a very straightforward way. And what is that? For every pixel, the same threshold value is applied. The threshold value is nothing but some kind of value that we fix. You can consider some kind of constant value. Means that value is the threshold, or you can consider as a limit. Below it, some other values will put for every pixel, and above it will put other values. So in this case, for every pixel, the same threshold value is applied. If the pixel value is smaller than the threshold, then it is set to 0. I told you, na. So if that value, pixel value is smaller than the threshold, then whatever the value is, we'll set it to 0. Otherwise, it is set to a maximum value. And the function cv.threshold is used to apply the thresholding. The first argument in this particular cv.threshold, actually the threshold is the function. We are taking it from CV, right? OpenCV. Now, the first argument here is the source image, which should be a grayscale one. The second argument is the threshold value, which is used to classify the pixel values. The third argument is the maximum value, which is assigned to pixels values exceeding the threshold. OpenCV provides different types of thresholding, right? And that is given by the fourth parameter of the function. In the fourth parameter, you have to specify which basic or which specific thresholding you are going to use. Now, what we have discussed here, whatever the thresholding process we are talking about, that can be done by typing cv.trace underscore binary, and this one particular method. There are different methods. I told you, the thresholding are different in this case. So like this one, trace binary, this is binary thresholding, and the others one are like trace binary, INV, trace trunk, trace to zero, trace to zero INV. So there are different of them. If you want to know more about them, if it requires, right, then you can go through the documentation, or you can specifically put a comment in the comment section. I'll discuss that particular function in detail, but I almost discuss the needed part for doing this practical. Now, this method returns two output. First is the threshold that was used, and the second output is our main aim, that is the threshold that image. Now, this is the code. You can take a screenshot here. This is my how I implemented here. Okay, using my own image dataset. Here I am using Lina image. I hope you all are now familiar with the Lina images. Sorry, this image is being used everywhere by the scientists and the researchers in this field for as a sample image. So same image I'm using here. So CV imread. This is the part where I am keeping the image Lina. And we are using OpenCV, so import CV2, but now as CV. Then from matplotlib, import pyplot as plot. Okay, so this means what? Now, next time you can directly use CV. No need to write CV2. Then next time you can directly write PLT without writing this pyplot. Okay, now these are the main code. Red, threshold 1, CV threshold, image, that original image, right? 127, 255, the values we have specified. Then CV trace binary, this is the binary one. Similarly, for other means thresholding types, we are using like trace binary INP, trace trunk, trace to zero INP. So these are the different methods. So accordingly, you will get different types of output. Obviously, this Lina is a color image. Now we are working with a gray version of it. Then accordingly, we are getting different outputs. So now the output will be shown like with these titles like image, binary, binary INV, trunk, to 0 INV, images IMG, threshold 1, threshold 2, threshold 3, threshold 4, threshold 5. Is IMG is the original image. Accordingly, these are the different thresholded version of the original image. So how many of them? 1, 2, 3, 4, 5, 6. So for I in the range of 6. We all know about the Python code, simple Python code for loop, right? So for I in the range 6, plot subplot, because we are subdividing the plot as per our need. 2, 3, I plus 1, plot image. So images I, gray, right? V means 0, V max 255. Gray version, you know the values are from 0 to 255. Then plot titles, title side, titles will be like this is the original version, original image. Then title will be what? 1. I am on titles 1 will be RMZ. Then threshold at 1. So accordingly, it will be picked up. So plot, X tick, plot, Y ticks, this, right? Then plot show. So accordingly, this X values, Y values. So these different versions of the thresholded image, this will be shown. First one will be the original one. So these are the 6 different images. So that's why we are using 2T, right? So this is the code. I hope I have explained properly each and every line of this code. Now let's come to implement this particular practical. For that, I'm opening the spider. You open your one. Well, you can see this code I have already written here so that I can save the time. Now, same code. No need to worry about same code. You just take a screenshot and you do it by yourself. So let's run this code. So for run, you can put F5 or run file. See, this is being run. Now, this is the output what we have got. See, if you are means first time using it, this particular output will not be means shown in the console one. For that, you have to go to this. You see my mouse cursor and untick the mute inline plotting. Accordingly, the images means output will be shown here. Otherwise, output will be shown in the plot version. So this is the original image. You can see this is the original image. This is the binary version, binary thresholded version. And how the thresholds are thresholded are means got here with the values that we are specifying. Like here, 127 to 55, the ranges we have specified. So similarly for binary INV, this is the output. Accordingly, different version like trunk, to 0 INV, these are the outputs. Well, so you do it with different types of images and you will get it and get to know about that how the thresholding exactly works. Remember, thresholding means dividing the images into one particular range. Means say X is the threshold value. Okay, so above X, say we are putting 1 and below X, we are putting 0. So that will be a binary one, 0 and 1, right? Similarly, the values if we are sending, accordingly we'll get different outputs. Well, that's everything about the common or normal, we can say general thresholding. In the coming classes, we are going more specific on the thresholding or thresholding concept. That's all for today. Thank you.